Hey everyone, Linus here, and today we're diving into the world of encryption. In the digital age, our lives are practically run by ones and zeros. From online banking to sharing those embarrassing cat videos, we're constantly sending information across the vast expanse of the internet. But how do we keep that information safe from prying eyes? That's where encryption comes in. Think of it as a digital lock on your data. It takes your information and scrambles it into an unreadable mess, making it impossible to understand without the proper key. This ensures that even if someone intercepts your data, they won't be able to make sense of it. Encryption is essential for protecting our privacy and security online. It's the backbone of secure websites, online transactions, and countless other digital interactions. Without encryption, our personal information would be vulnerable to hackers and cybercriminals. So, buckle up as we explore the fascinating world of encryption and learn about the different methods used to keep our data safe. First up, let's talk about symmetric encryption. This method is like having a single key that can both lock and unlock a door. You use the same key to encrypt the data and then decrypt it again on the other end. One well-known example of symmetric encryption is the Advanced Encryption Standard, or AES. It's like the Fort Knox of encryption. Super secure and used everywhere, from password managers to disk encryption. Then there's the older Data Encryption Standard, or DES. It's like that old lock you have in the back of your drawer. It still works, but not as strong as it used to be. Symmetric encryption is great for speed and efficiency. It's like sending a package through a pneumatic tube. Quick and easy, but there's a catch. How do you securely share that single key with the recipient? If someone gets their hands on it, your data is compromised. That's where asymmetric encryption comes in, but we'll get to that in a bit. Stay tuned. Now let's move on to asymmetric encryption, also known as public key cryptography. This method is like having two keys, a public key and a private key. The public key, as the name suggests, can be given to anyone. You can post it online, shout it from the rooftops, whatever you like. The private key, however, is your secret key that you never share with anyone. Think of it like a mailbox. Anyone can drop a letter into the slot, public key, but only you have the key, private key, to open the mailbox and read the letter. RSA and ECC are two popular examples of asymmetric encryption. RSA is like the trusty old mailbox that everyone knows and uses, while ECC is like the new sleek mailbox with all the latest security features. It's faster and more efficient while still being incredibly secure. Asymmetric encryption is perfect for situations where you need to share encrypted data with someone you haven't met in person to exchange keys. It's like sending a secret message in a bottle. Only the intended recipient with the right key can open it. Section 4, hash functions, digital fingerprints. Now let's talk about hash functions. These are like digital fingerprints for your data. A hash function takes your data, no matter how large or small, and generates a unique and fixed-length code. Think of it like this. You can take a whole book, like Lord of the Rings, and hash it down to a single unique code. Change even a single comma in the entire book, and the hash code will change completely. SHA-256 and MD5 are two popular hash functions. SHA-256 is like the high-security fingerprint scanner used by government agencies, while MD5 is like the fingerprint scanner you might find on a phone, still useful, but not as robust. Hash functions are great for verifying data integrity. If the hash of a file has changed, you know that the data has been tampered with. They're also used in password storage, where your password is hashed and stored, so even if the database is compromised, your actual password remains safe. Section 5, hybrid encryption, the best of both worlds. So we've learned about symmetric and asymmetric encryption, each with its strengths and weaknesses. But what if we could combine the best of both worlds? That's where hybrid encryption comes in. This method uses the speed of symmetric encryption for the actual data encryption and the security of asymmetric encryption for sharing the encryption key. It's like sending a package through that pneumatic tube. But this time, the key to open the package is sent separately using a secure mailbox. One of the most common examples of hybrid encryption is Transport Layer Security, or TLS, the technology that secures your connection to websites. When you see that little padlock icon in your browser's address bar, you know that TLS is hard at work protecting your data. Section 6, Encryption in Action, protecting your digital life. So there you have it, a crash course in encryption. From symmetric and asymmetric encryption to hash functions and hybrid systems, we've covered the basics of how these methods work and where they're used in our daily lives. Remember, encryption is crucial for protecting our privacy and security in the digital age. It's like a shield against the constant barrage of online threats, safeguarding our sensitive information from prying eyes. So the next time you're shopping online, checking your bank account, or sending a confidential email, take a moment to appreciate the magic of encryption working behind the scenes to keep your data safe. And that's the bottom line.